Alright, we are now on example number 4. If you look at this example number 4, it's a cantilever beam, but anytime you have a cantilever beam with a support at the end, it's nothing but a what? A probed beam. And if you look at this, this is the hinge, and from this hinge to the fixed support, to the fixed end here, we have a what? A bearing distributed load. But this bearing distributed load, we can treat it as a what? Uniformly distributed load. Yes. So if we are going to do that, when we convert this to a point load, it's going to act at what? The center of the what? This. But I'm still going to show you. You can treat them separately. I'm going to take that part of separate, and you will solve the other way around. Then when you finish solving, you can post your solving in the what comment section, and I'll go through it. I would like to see that. Okay, so you can see this uniform distributed load. It is inclined at what? Angle 30. And this angle 30, it is inclined at what? Y-axis. Please take note of that from resolution of force. From resolution of force, when it is inclined with what? The vertical y-axis, this thing, for you to consider it like this, when you want to resolve this, when you are resolving, your y-axis is going to be what? It's going to be what? If you can remember, that is what? Cos. And your horizontal is going to be what? Sine. But if you want to take it in the normal way, if you subtract 90 from this one will be what? 60. Then you cannot take sine 60 cos 60. I hope you get that. Okay. So now, the first thing we are going to do is to convert them to a point load. Let me start with this part. So this is A equals to length times what? Breadth. A will be what? 2 times 5, which is what? 10 kilonewton. So the next one, we want to take them. If I'm taking this point, if you look at this and this, so this is my 90, this one will be my what? 90. Separate what? Separate UDL. I just want to take that. Let's call this place point B. So if from here to here is 5, it means from here to B is what? 2.5. From here to B to C is also what? 2.5 meter. I hope you get that. So now, the next thing here, let's convert the two of them now to a point load. You know they have the same value, 2.5, and the height is what? 4. So A is nothing but half base times height, which is half, times 2.5 times 4, which is 2 here 1, 2 here 2. 2.5 times 4 is nothing but what? 5 kilonewton. You get that? So the next thing we are going to do now is to separate them. And when we are separating them, I'm drawing the free body diagram. Do you still remember how to draw the free body diagram for this? From our previous video? Yes. This is going to have is going to have both vertical and horizontal reaction and a what? Moment. So from here to here B. So it's going to be like this. RA, HA, and a moment. MA. So this is our point C. Let's leave that. Let me just name this place point C. So here I'm having RE because it is a roller support. So don't forget that let me say this place is my point D. You get that? Okay, so now this place is my point D. When you convert a uniform distributed load to a point load, it's going to act at what? The center. So from here to here is 2, so it's going to act at what? 1 meter, 1 meter. So this place like this, and this one like this. So we are going to resolve it into a what? Into a vertical and horizontal component. But I will take it direct the way it is like this. It is making angle with the what? Y-axis. So if I'm to resolve it, this one is going to be what? It's going to be what? I've said it the other time. 10, because the point is 10 cos 30. Why this one is going to be what? 10 sine 30. If you want to take it in the normal way, just subtract 30 from 90, that is 60. Then this one is going to be what? Sine 10 cos 10 sine 60, 10 cos 60. You can solve it that way, you still arrive at the same answer. So this place is 3 meters. So now this thing is let me take this point to be what? Upward first. Let me take this one to be what? Downward first. Let's take this to be like this and this to be like this. So this one will be HC, HC, ROC, ROC, right? Now, the length at which this uniform distributed will act. You know this one is going to act away from 90, this one too will act away from 90, and they will both act at what? L/3. So 5, and the total length is what? The total length for this is 2.5. Total length for this is also 2.5. So it's going to be 2.5/3. And 2.5/3 is nothing but 0.83. 0.83. Press your calculator to confirm that. 0.83. Okay, so now let's do something now. From A to B, let's place this my B. This my B, right? So for this point now, it's acting at what? L/3 away from this 90. So and from this point to this point is what? 2.5. So this place to be here, and it is 5 kilonewton. 5 kilonewton, right? So it's going to act at what? 0.8 meter away from this 90 degree. And if you want to get the other side, 2.5 minus 0.8. Press your calculator. That is 1.67. 1.67 meter. I hope you get that. So now from this B again, on this point B, this one too, when you divide it L/2.5, you are still going to get 0.83, and it's going to act at what? It's going to act at 0.8 away, 0.83 meter. It seems that they are becoming clumsy. Let me take this like this. So 0.83 meter, so which is still 5 kilonewton. So the other part will be what? 1.67 meter. If you add all this together, you are going to get 5 meter. So I hope you get this now. So now if you look at this one now, this point load. Now this point load, where will it be? Is it at this beam? Will it be at this beam or at this beam? Now it will be at the one that you want to consider last. Do you get that? I want to consider this one last. I'm going to put it there. Do you get that? So let me put it here because I want to consider this point last. 10 kilonewton. So now let me solve this one first. So considering beam, we are starting with beam C, D, and E. C, D, E. So we are starting with summation of horizontal force to be 0. It means that this should be positive. So it means HC. HC minus what? HC, no, this is my, we are having 10 sine 30 going like this, so it's going to be negative 10 sine 30 to be equals to what? 0. So it means HC will be equals to 10 sine 30. And don't forget that sine 30 is half. So 10 divided by half is what about what? 5 kilonewton. I hope you get that now. So my neck is paining me. It's not easy. So now the next thing is to take our what? Is to take our summation of vertical force be equals to 0. Vertical force, ROC, vertical force, okay, this one is a downward force. Vertical force, we have ROE minus ROC minus 10 cos 30 equals to what? 0, right? So if this one cross to the other side, it's going to be ROE minus ROC equals to 10 cos 30. And if you press 10 cos 30, let me try that with my calculator. Since the calculator is too stubborn, the battery is becoming low. Okay, let me leave that. I already solved it here, but let's leave that like this. So let's take this as our equation 1. Okay, so the next thing is to take our what? Moment. We are going to take moment, clockwise moment to be positive about what? Point C be 0. So now if we are taking moment about this point, it means that this one will give us what? Anti-clockwise moment, while this one will give us what? Clockwise moment. Please don't get confused with this. If you look at this now, it's going to go like this. It's going like this with the hand of your clock, clockwise. Do you understand? And this one is going like this, anti-clockwise. That is just all we mean by that. So, and you look at the distance it covers, which is 4. So it's going to be 10 cos 30 times 4. You understand? Minus ROE times the total distance, which is what? 5 equals to what? 0. So 5 ROE 10 cos 30 times 4. 10 cos 30 times 4 is nothing but 34.63. 34.63 equals to, this one come back to this, we are going to have 5 ROE. So for you to get your ROE, is going to be 34.63 over 5. 34.63 over 5 is nothing but 6.928. 6.928 kilonewton. You get that? Okay. So now that is ROE. Can we get any other thing there? Can we get ROC? Yes, we can get ROC. From this equation, we have ROE minus ROC to be equals to what? 10 cos 30. So we've gotten our ROE. If I take this, my ROC back here, and I bring this one back here, I'm going to have ROE minus what? 10 cos 30, which is 6.928 minus 10 cos 30, which is equals to what? ROC. So it means that ROC will be equals to, if you confirm this with your calculator, you are going to have minus 1.732. Minus 1.732 kilonewton. So it means that ROC is equals to 1.732 kilonewton. Look at the absorption for ROC for this second beam is what? Downward. The negative is telling you that it should be what? Upward. Very interesting. Do you get that? So now let's consider the second beam now. The second beam now. So we still start with horizontal force. Summation of horizontal force equals to 0. So do we have any horizontal force there? Yes, we have HA. HA is going in the same direction with this positive. This one is negative. Minus HC equals to 0. It means HA equals to what? HC. Both of them are both equals to what? 0. So now the next thing is to take our summation of vertical forces. Don't forget that our ROC here is what? Upward force, which is 1.732. It's supposed to be what? Upward. So when it is upward here, it means it will be downward here. So this is no longer upward but what? Downward. You get that? So now we have ROA minus ROC minus 5 minus what? 5 equals to what? 0. So it means ROA minus ROC, which is 1.732 minus 10 equals to what? 0. So ROA will be equals to minus 1.732 minus minus 1.732 minus 10. Let me confirm this. I did not solve this here. Minus 1.732. 1.732. Oh, sorry. I think. Yes, please, sorry. there is 10 kilonewton here. Yes, please, sorry, I was looking at it. I know it's not complete. See, we have 1, 2, 3, 4 forces. So, and it's also a downward force, so it's going to be minus 10 equals to what? 0. So it's going to be RA minus 1.732 minus 5 minus 5 minus 10, that is minus 20 equals to 0. So if you sum this together, minus 1.732 minus 20, that is that is minus 21. Oh, sorry. Look out. I'm still going to go and press this in calculator. I'm sorry. I started this for you. So RA, that is minus 21.732 equals to 0. If this goes to the other side, RA will be equals to what? 21.732. You get that? So now, which is in what? Kilonewton. You get that? So now, do we have anything that will work? Okay, we'll calculate there. We have MA, which is our moment. So let's take moments now. We take moment about A. If we take moment about A, clockwise moment about A, positive. So we are going to have 1, 2, 3, 4 forces. You get that? And this one give us a what? And this one will give us a clockwise moment. But this one will give us a what? Anti-clockwise moment. Why the moment himself that is here is what? Anti-clockwise moment. So 5 times is going to be 5 times what? 1.67 plus what? 5 times the total distance of this 0.83 plus 1.67, right? So that is 13. Carry 1, 9, 17, 23. So that is 3.33 plus 10 times the total distance, which is what? 5 minus RC times 5 equals to what? 0. But my RC is already what? 1.732, right? So it means this will be 5 times 1.67 plus 5 times 3.33 plus 10 times 5 minus RC. Please, I did not add this moment, sorry. Minus NA equals to what? 0. Minus RC times 5 minus NA equals to what? 0. But RC is already 1.732 times 5. Yes, like this. I hope you get that. So now, I'm going to press all this in my calculator. 5 times this, 5 times this plus 5 times this minus this. But let me try if this calculator is working perfectly now. The battery has run down. Please, you can press this in your calculator yourself. I already solved this here. I got 83.66. If you press all this in your calculator, if I take this one back here, it's going to be what? NA. So NA will be equals to, if you press all this in your calculator, this times this plus this times this plus this times this plus minus this times this, you are going to have 83.66 kilonewton meter. Please don't forget the unit of moment. So that is all about the question. Thank you. Please don't forget to share with your colleagues. Thanks.